Hey, you guys, and welcome to the Fundamentals of Computing Chapter 6. Okay, so we are now on the Chapter 6. Ang bilis ng panahon. Okay, so for this video, in this chapter, we will be discussing about the different, the continuation of the computer components. Okay, we will discuss about the hardware and software and the number system and also the number conversion. So I think the hardware and software was already discussed from the previous chapter. So what we're gonna do is just to, recap para mas maunawaan natin. Mas maganda kasi yung lagi natin siyang dinidiscuss para talagang you will gonna keep it in your mind. Okay, so let's talk about hardware. Again, a hardware, it represents the physical and tangible components of a computer, and I believe you know that already. So the components can be seen and touched. We have this input devices, we have keyboard, mouse, light pen, and any other keyboard, any input devices. And also we have these output devices. It's very familiar that we know what the printer is all about, a monitor, secondary storage, we have the hard disk, CD, DVD, internal components, we know what CPU is, a motherboard, a RAM, and etc. Okay, so that is a hardware, all tangible components of a computer. Okay. Okay, what is the relationship between hardware and software? So hardware and software are mutually dependent on each other. Okay, both of them must work together to make a computer produce a useful output. Okay, so the software cannot be utilized without supporting hardware. Hardware without a set of programs to operate upon cannot be utilized and is useless. Okay, so to get a particular job done on the computer, relevant software should be loaded into the hardware. Okay, so the hardware and software must work together. Okay, so hardware is a one-time expense. Again, it's a one-time expense, you just, buy the components. And then the software development is very expensive and is a continuing expense. Okay, as you may have observed that there are a lot of applications nowadays really, updating and the softwares are upgrading. Okay, and yeah, so the different software applications can be loaded in a hardware to run different jobs. And then software, it acts as a user. Wait, let me move this one. As this, different software applications can be loaded on a hardware to run different jobs, and a software acts as an interface between the user and the hardware. So if the hardware is the heart of the computer, then the software is its soul. So both are very important. No, wait, sorry. So both are complementary to each other. Okay, so again, sorry. Your computer will not work without the hardware and without the software. So the software and hardware must work together for them to give you a useful output. Okay. Next, let's move forward with the software. Of course, a software is a set of programs which is designed to perform a well-defined function. Okay, it is a program or is a sequence of instructions written to solve a particular problem. So there are two types of software. We have the system software and we also have this application software. Okay, so when we say system software, it is a collection of programs designed to operate, control, and extend the processing capabilities of a computer itself. Okay, so this is generally prepared by the computer manufacturers. And these computer products comprise of programs written in low-level languages. When we say low-level languages, guys, this is a very hard language actually. Okay, which interact with the hardware at a very basic level. Okay, um, system softwares serves as the interface between the hardware and the end users. And some examples of the system softwares are, operating systems, compilers, interpreters, assemblers. So here's the examples. We have Windows, Linux, iOS, the operating systems, yeah, Android, Ubuntu, and yeah, so these were system softwares, okay? When we say application softwares, okay, let's move this one. Okay, so when we say application softwares, these are products are designed to satisfy a particular need of a particular environment. Okay, so all software applications prepared in a computer lab can come under the category of computer application. So, application software. Application software may consist of a single program, such as, Microsoft's Notepad for writing and editing simple text. It may consist a collection of programs, often called a software package, and which work together to accomplish a task, such as, spreadsheet package or etc. Okay, and I believe you have idea about the different applications. I All of us here are using social media applications. We also have the shopping applications. We have Lazada, Shopee, something like those things. So those programs that can perform single task for user satisfactions. So we have this Photoshop, Gmail, Google Docs, Google Spreadsheets, and etc. Okay, so those were the application softwares. Okay, some examples. We have payroll system, payroll software. We have the student record software, inventory management systems, income tax systems, railways reservation software. We also have Microsoft Office suite software, Microsoft Word, Microsoft Excel. Oh, I have a mistake again. It should be in here. Okay. Ayan. Microsoft Excel, and then Microsoft PowerPoint. So these were some of the examples of the application software. So I hope you guys have, get the difference between the system softwares and then the application softwares. Okay. So the features of the application softwares are as follows. We have it is close to the user, it's easy to design, it's more interactive, and of course, it is slow in speed and generally written in high level language. When we say high level language is, a language that is more easier to program, to create, and much more understandable by the end user, by the developers who creating those programs, those applications. Okay, and easy to understand. Sorry, I have a mistake again. Let me correct this one. Okay, it is easy to understand, easy to manipulate and use, easy to manipulate and use, and it has bigger in size and requires large storage space. Okay, so those were the different application software features. Okay, so I hope you guys have learned about, hardware and software. It's pretty easy, right? And it's self-explanatory, when you say hardware, it's tangible things. When you say software, it's non-tangible. It's something that you create and then install it computer, or the way how the computer handles all the outputs, all the instructions you have given to him, you've given to the computer, then that's it. Okay, so we're going to talk about the number system and what is the number system and why is it important. Okay, so a number system, when we type some letters or words, the computer translates them in numbers. Okay, so as computers can only understand numbers. So for example, when you type in any word, okay, any word, you give an instruction to your computer. Let us say you chat to your crush. Ingon ka dito, sabi mo, I love you. No? I love you, mahal na mahal kita. Sana oil. Okay, so those words will be translated into numbers that the only computer understands. Okay, so a computer can understand the positional number system where there are only a few symbols called digits. Again, symbols. gold digits, and these symbols represent different values depending on the position they occupy in the number. So it's very important that we should know what a number system is in order for us to, imagine the how the computer um, translates everything to give us really great output. Okay, so the value of each digit in a number can be determined using, of course, the digit, and we also have the position of the digit in the number. So in here, it's very important to where the number is positioned, and then the base of the number system. So the base of the number system, where the base is defined as the total number of digits available in the number systems. Okay, understand? Hope that you understand. Okay, again, this is a number system. So it's very important that we should understand the number system. Okay, so first is the decimal number system. DC means 10. Okay, 10 decades, or yeah. The number system that we use in our day-to-day life is the decimal number system. So decimal number system has a base 10 as it uses 10 digits from 0 to 9. Kaya again, 0 to 9. Pag mag-count mo, pinunin niyo ang 0. So start kag 0 as 1. Then pag abot siya 9, that is 10. So that's 10 digits from 0 to 9 including 0. Okay? So in decimal number system, the successive positions to the left of the decimal point represents units, tens, hundreds, thousands, and so on. Okay, so its position, its position represents a specific represents a specific power of the base 10. So for example, the decimal number 1234 or 1234 consists of the 4 digits in the units position. Okay, 3 in the tens position, 2 in the hundreds position, and 1 in a thousands position. So each value can be written as 1. Oh, sorry guys, I have a mistake again. Let me correct this one first. Okay, so sorry for the mistake. Okay, and oops. Okay, so let's go back to our presentation. Hindi kasi naayos yung pagkalagay ng exponent, kaya ano na lang, nilagay ko na lang yung screenshot niya. Okay, so this is how you do it. We have this number 1, 2, 3, and 4. 1, first is 1, you multiply it by 1,000. No, since the position of 1 is in 1,000. 2 for hundreds, 3 for 10, and then 4 for 1. Okay, so 1 times, decimal number system, a DC. When we say DC, it is a base 10. So all you have just to do is to multiply it by 10, and then you check out the position. Okay, let us say, for example, 1, 2, 3, 4. This is 0, 1, 2, 3. So 1 multiplied by 10 to the power of 3. Okay, 2 multiplied by 10 to the power of 2. 3 multiplied by 10 to the power of 1. And 4 multiplied by 10 to the power of 0. So 10 to the power of 0, when the exponent, is 0, the answer would always be 1. Okay, so 1,000, 10 to the power of 3 is 1,000, and then to the power of 2 is hundreds. Okay, so 1,000, 2 times 100, 200, 3 times 10 is 30 plus 4. 4 times 1 is 4. So that we're gonna give us a 1, 2, 3, 4. Okay, so that is how the computers, read it in a decimal way. Okay, so don't worry guys, because there are a lot of examples that I will be giving to you. Kaya relax lang muna kayo. Okay, so as a computer programmer or an IT professional, you should understand the following number systems which are frequently used in the computers. Okay, we will be using binary, octal, and hexadecimal. So when we say binary, it uses only two digits. It's zero and one. So actually the zero is equivalent to on and one is equivalent to off in a computer switch. Okay. So that's the base two. Again, there's only two digits, zero and one, when we say binary. Okay. And then in an octal number system, it is base eight. So the digits are from zero to seven. So again, you start the counting from zero. So from 0 to 7, that's 8 digits. Okay. And we also have hexadecimal, which is from digits of 0 to 9. And letters used is from A to F. So that's from 0 to 9, that's 10 digits. From A to F, that's 6. Okay. And that will going to give us 16 digits. Okay. Don't worry, guys, because mabala na nato ng anong naa si binary, octal, hexadecimal. Okay, so the binary number system. Again, it uses only two digits, which are the 0 and 1. It is also called as base 2 number system. So the base is 2. So each position in a binary number represents a 0 power of the base 2. So example, 2 to the power of 0. Okay. Last position in a binary number represents a x power of the base 2. Okay? So example, 2 to the x, where x represents the last position or 1. So the computers use the binary number system to manipulate and store all of their data, including numbers, words, videos, graphics, and music. Okay, so let's take a look at this example. Example, I have these binary numbers 10101 to the base 2, and I wanted to convert it into decimal. So again, what is the decimal? Decimal is base 10, right? So the step 1 is you're going to get all the positions of the numbers and then multiply it by base 2. Okay, so let's take a look at this one. 1 multiplied by 2 to the 4. It's because we're going to get the position of the digits. This is 0, 1, 2, 3, and 4. Okay, so 1 multiplied by 2 to the 4, 2 to the 3, 2 to the 2, so on and so forth until it reaches to 0. Okay, so 1 multiplied by 2 to the 4, that's 16. Okay, and then 0, of course, you need to just crush this out because 0 multiplied by any number is 0. 0 to the power of 2 to the 1. Okay, I'm gonna crush that out. And then 16 plus 4 plus 1, that's 21 to the base 10. Okay, so that is how you're gonna convert binary to decimal. Don't worry, because we have another examples for this. Okay, and we also have octal number system. So again, binary is 1 and 0. We also have octal number system. The octal number system again is base 8. So it uses digits from 0 to 7. Okay, so its position in an octal number represents a 0 power of the base 8. And the last position in the octal number represents as x power of the base. Okay, so if we take a look at this example, if we want to calculate from octal number to decimal, again, octal number base 8 to um, decimal number base 10, all we have just to do is ganina sa binary, atong i-multiply sa iya is 2. No? Karon, atong i-multiply sa iya is 8. Kay octal man. Okay? So again, you get the position 0, 1, 2, 3, and 4. So 8 to the power of 4, 8 to the power of 3, to the power of 2, so on and so forth. You get this number, mo na din ang multiply sa iya. Okay? And then you calculate. Then, this step 3, that's it. You're going to give you the decimal value. So, Note that the octal number is normally written as this one, where it doesn't have, um, the base 8. Okay, so again, octal number is 8, base 8. Binary is base 2. Okay, so don't worry about the examples because natin mga examples daghan. We also have hexadecimal. Okay, hexadecimal, it uses 10 digits from 0 to 9 and then 6 letters from A to F. Okay, so letters represents the numbers starting from 10 to 15, where A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13, and sorry, A is equal to 14, and F is equal to 15. So it is also called as the base 16 number system. Okay, so each position in an hexadecimal number represents a zero, power of the base 16. Okay, and then the last position in the hexadecimal number represents x power of the base 16. Okay, so again, sa binary, atong i-multiply kay 2. Sa octal, atong i-multiply kay 8. Kaya nga ng base 8 man, okay, think about of an octagon. Now, an octagon has a sides of 8, so dira nagiko ang concept now that it is in the base 8. Okay? So don't worry, kasi na video ako ipakita sa inyo for you to mas masabtan pa niya, mas makalearn pa mo. Okay? So again, you get the position. Now, if this is an hexadecimal number and we want to convert it to decimal, which is the base 10, all you have just to do is to multiply it by 16. Then you get the position of the number. So this one, sample na to, 0, 1, 2, 3, and 4. So that's 16 to the 4, 16 to the 3, 16 to the 2, so on and so forth. So again, letters is equivalent to ano siya. So for example, F. F is equivalent to 15, right? And then D is equivalent to 13. And E is equivalent to 14. Okay, so just multiply and then add. Then we're going to give you a decimal number. Okay, so again, the binary base 2. The octal is base 8. And then the hexadecimal is base 16. Okay, so those were the different number system. Okay, so using binary system, 1 plus 1 is equal to 10. Why? Because 2 does not exist in this system. So there is no 2, number 2, 3, 4, 5, 6, 7, 8, 9, 10 in a binary. It's only 1 and 0. Okay, a different number system. Wait, let me move the igakatambunan siya. Okay, so a different number system, the commonly used decimal. The commonly used decimal or base 10 number system counts by using 10 digits from, again, 0 to 9. So in decimal, 1 plus 1 is equal to 2 and 7 plus 7 is equal to 14. So another number system used by computer programmers is the hexadecimal or the base 16, which uses 16 symbols from, again, 0 to 9 and then 8 to F. So in hexadecimal, 1 plus 1 is equal to 2 and 7 plus 7 is equal to E. Now it's no longer 14. It becomes a letter symbol ng E. So base 10 and base 16 number systems are more compact than the binary system. So programmers use the hexadecimal number system as a convenient, more compact way to represent binary numbers because it is very easy to convert from binary to hexadecimal and vice versa. So it is more difficult to convert from binary to decimal and then from decimal to binary. So the advantage of the binary system is its simplicity. Yeah, because 1010 lang. So a computing device can be created out of anything that has a series of switches. So each of which can alternate between an on position or an off position. So again, when you say 1, that is the on position, and then 0 is the off position. Okay, so these switches can be electronic, biological, or mechanical as long as they have They can be moved on command from one position to other. So most computers have electronic switches. So when a switch is on, it represents the value of 1. When the switch is off, it represents the value of 0. So digital devices perform mathematical operations by turning binary switches on and off. So the faster the computer, oops, sorry. The faster the computer can turn the switches on. What's going on? Wait. Turn the switches on and off, the faster it can perform its calculations. Okay, so again, when we give instructions to the computer, it will convert, the data that the words or text that we input into numbers. Because numbers naman ang yaang kakabalan. Okay, so here's one of the table. So the binary from 1, 0 to 16 is, okay, sample, the decimal number is, this one, 0 to 16. If you convert it to binary, this is what we're gonna happen. Okay, muna yung equivalent. Same with the hexadecimal. Okay, so those were the numbers. Now let's try to convert, the number conversion. Let us say from binary to octal to binary, and then hexadecimal to octal, something like those things. Okay, so there are many methods or techniques which can be used to convert numbers from one base to another. We have decimal to other base systems, other base system to decimal, and other base systems to non-decimal. We also have the different shortcut methods for, binary to octal, octal to binary, binary to hexadecimal, and hexadecimal to binary, and vice versa. Okay. So from decimal to other base system, again, the number is a decimal, to any other base system. It could either be octal or could either be hexa. So first that you're going to do is to, let us say, decimal to binary. Okay, divide the decimal number to be converted by the value of the new base. Step 1, let us say the decimal number is 29. No? 29. 29, what is the base of binary? 2. So 29, you divide by 2, the result is 14. Okay, 14.5. So to get the remainder, 0.5 multiplied by 2, that's 1. Okay, so the step 2 is you get the result, you divide it by 2. Okay, 14 divided by 2 is 7, remainder is 0. Step 3, step 2 is get the remainder from step 1 as the rightmost digits, or this is the least significant digit of the new base number. Step 3 is divide the quotient of the previous divided by the new base. Okay, so let us say 7 man tiyang result ganina, 7 divided 2 is 3, 3.5, right? 0.5 multiplied by 2 is 1. Okay, so that's remainder 1. 3, 2, so on and so forth until nga 0 na ang result. Okay? So step 4, record the remainder from step 3 as the next digit to the left of the new base number. Repeat the steps from 3 and 4, getting remainders from right to left until the quotient becomes 0. Okay? So the last remainder thus obtained will be the most significant digit. So the most significant digit is from bottom to up din ka, muni imong least significant digit. So para makuha ni mong answer from, decimal to binary, divide naman nimo sa 2, di ba? And gikuha nimo remainder, that would be 1, 1, 1, 0, 1. Start ka dito. Okay, so as mentioned in steps 2 and 4, the remainder have to be arranged in the reverse order from bottom to top, so that the first remainder becomes the last significant digit. Okay, I mean, the first remainder becomes the least significant digit, or LSD, and then the last remainder becomes the most significant digit, or MSD. Okay? So, as for our example, 29 to the base 10, iyang binary ana is 11101 to the base 2. Again, ang imong kaon lagi ani is the remainder. You divide it to 2. Kung decimal to decimal to octal, so pila man imong i-divide dire? 8. Yung hexa, 16. Okay? So other base systems to decimal. So when we say binary to decimal, octal to decimal, hexa to decimal, first is you need to determine the column or the positional value of each digit. Now, this depends on the position of the digit and the base of the number system. Next, you multiply the obtained column values in step 1 by the digits in the corresponding columns. Step 3, sum the products calculated in step 2. The total is the equivalent value in the decimal. Okay, so let us say, for example, you have this number, you have this binary number, and you wanted to convert this to decimal. All you have to do is to, again, check the position. How to get the position of this one? 0, 1, 2, 3, 4. Okay? You put an index. 0, 1, 2, 3, 4 sa kada number niya. And then, 1, you multiply it by, again, base 2. Kay binary man eh. 2 to the 4, 2 to the 3, 2 to the 2, so on and so forth. Step 2, you multiply the obtained column. Okay, you multiply, 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 and then add tanan. That's a base 10. Butang ni mag 10 dara. So the step 3 is, add tanan. So mo din na siya ang answer, 29 to the base 10. So the binary 111012 base 2 is equal to the decimal number of 29 to the base 10. Okay? So yun sa mo siya. So kung let us say you want to convert octal to binary, octal to decimal, you want to get the decimal, just do is to replace rin mo pilaman 8 and then check the position. Okay? So other base system to non-decimal. Step 1 is you need to convert the original number to a decimal number. Okay? And then convert the decimal number so obtain the new base number. So let us say octal, you wanted to convert the octal to to binary and not to decimal, sorry. So step 1, convert the original number to a decimal base 10. Okay, so again, pila itong base 8 ay pila itong base sa octal, it's 8. 8, you get the position 0, 1. So again, ano siya? Then you multiply, then you add. Okay? So there's also a shortcut methods, but I will not be, discussing that one. Kay lisod kayo siya nga magsulat-sulat ta dire. So what you're gonna do is to check this video. This is one of the most very easy tutorial, and this is one of the amazing tutorials so far. Okay, you check this out. This is 30-minute. So you will know and understand more about the decimal, the binary, the octal, the hexadecimal, and then the BCD conversions, or the binary to octal, hexadecimal to octal, binary to decimal, something like those things. So I'd like you to watch this one because it's very easy to learn, and nanagid siya mga examples. Okay, so that would be for the chapter 6. So thank you so much, and I hope that you are learned so far, about the different hardware and software components, and also the number system. Why is it important? Why do we need to learn about this? And also the number conversion. So take a look at this video for you to be able to learn more. Okay? So that's all, and God bless. Keep fighting, everyone.